In this next example, we're adding in an initial condition that this is going to pass through the point 2, -1/3. So that's just like when we did the acceleration and distance and speed problems, where we would have an initial condition that would allow us to plug in and find the value of c. It's going to be the same thing here. So we're told that the slope, that is dy dx, is y squared times x. So if we separate that, as we've been doing, we have 1 over y squared dy equals x dx. And so we need to then anti-differentiate both of those. We might want to think of this as being a y to the -2nd there. And so if we raise the power by 1, it's going to be y to the -1st, or 1 over y. And multiplying or dividing by the new power, which is -1, we get a negative in front of that. Be careful on those. A lot of times people want to throw in natural logs on those. That's just when it's 1 over y, not a 1 over y squared. And then that equals 1/2 x squared. And we have the plus c there. Let's plug in our point and find our initial value of c. So -1 over y, if y is -1/3, that's going to be 3, is equal to 1/2 times x squared. X squared is going to be 4, and half of that is 2. And so c must be 1. And so we have the equation -1 over y equals 1/2 x squared plus 1. And again, we could do things and manipulate that depending on what we're trying to do, but that is an equation of that curve. It didn't tell us it had to be in any special form, so we'll just leave it right there.